Okay, now let's have a look at question 5a. B and C are done exactly the same way. And I'd like to remind you of this little doohickey here. Now, that's the discriminant. And you should remember the discriminant is the bit under the square root in the quadratic formula. B squared take 4ac. And this is where our generic form is y equals ax squared plus bx plus c. So, for question 5a number 1, we have the discriminant equals, well, the actual formula we've got is y equals 1x squared. We've got no lots of x, and we've got a plus 2 afterwards. So here, a is 1, b is 0, c is 2, which means our discriminant is 0 squared, take 4 times 1 times 2, so it comes out as -8. And don't forget, when we're using the quadratic formula, and I'll write it up here, x equals minus b plus minus the square root of b squared take 4ac all over 2a. So the quadratic formula is literally this bit. Oh, I wish I'd used a different colour for that. Let me do that again. Purple. Literally that bit. When that's negative, you can't square root it, so you get no x-intercepts. So, which is less than 0, so it's negative, so no x-intercepts. Which means it happens all either above or below the parabola. Well, in this one, it'll be all above because it's a positive. For question A2, what do you notice about the y-intercept and the vertex? Well, I've actually got a hunch that they're going to be the same thing, but let's actually do that. So, y-intercept. Don't forget you let x equal 0. So y equals 0 squared plus 2, so it's going to come out as 2. And the axis of symmetry, x equals minus b over 2a, which for this one is going to be minus 0 over 2 times 1, which is just 0. And the y-coordinate, well, we're subbing in 0, so obviously the y-coordinate is 2. They're the same. So if we sketch it, oh, come on, I can do a straight line. I'll call this 1, 2, 3. And this is my y, and this is my x. The y-intercept is positive 2. No x-intercepts. It's going to go up like that. Sketch the point where x equals 1. Well, if x equals 1, y equals 1 squared plus 2, which is 3. So really, I should have had this going through x equals 1, y equals 3. So it should go up like that. Like that. Let me fix this up. There we go. That looks a bit better. Another point found by symmetry. The other point found by symmetry bit means that it must also go through this one because they're symmetrical. So, yeah. We kind of do that automatically. That's question 5. Not too hard. If we then look at question 6, I'll do 6C because that looks harder. Let's do 6C. So, we get these funky formulas. I'm just going to write my thing down. Minus 3x squared plus 10x take 5 equals 0. We're trying to find the roots. So, don't forget to find the roots. We use the quadratic formula. Here A equals minus 3, B equals 10, C equals minus 5. So the quadratic formula, x equals minus 10 plus minus the square root of 10 squared, take 4 times negative 3 times negative 5. Wish I'd been able to fit that in better. All over 2 times negative 3, which is going to give me negative 10 plus minus the square root of 100, take 60. All over negative 6, which is x equals negative 10 plus minus the square root of 40 over negative 6, which gives me x equals negative 10 plus minus, what goes into 40? 4 and 10, nothing bigger? No. So that's 2 root 10 all over negative 6. Divide everything by 2. I could have factorized, but we're going to go straight into that. Negative 5 plus minus root 10 over negative 3. Divide everything by negative at least. X equals 5 minus plus, same deal, root 10 over 3. And they want to prove that these roots, if we add them together, we get minus b on a, and if we times them, we get c on a. Let's actually do that. So, our roots, I'm going to let alpha equal 5 take root 10 on 3, and beta equals 5 plus root 10 on 3, which means alpha plus beta, 5 take root 10 on 3 plus 5 plus root 10, that's a 10 on 3. So 5 take root 10 plus 5 plus root 10 on 3 gives me 10 on 3. They want me to show that, let's have a look at the actual question, that equals minus b on a. Minus b on a, well, b was 10, so we've got negative 10. A was negative 3. The negatives cancel out, 10 on 3. So we've shown it. Alpha plus beta equals minus b on a. And that always works. The other thing they want us to show is that, let's have a look, alpha times beta equals c on a. So alpha times beta for us is going to be 5 take root 10 on 3 times 5 plus root 10 on 3. Don't forget, in multiplying fractions, you times the top, you times the bottom. So 5 take root 10, 5 plus root 10. It's going to come out on 3 times 3 is 9. I'm going to expand, first times the first, first times the second, second times the first, second times the second. So 5 times 5, 25. 5 times root 10 plus 5 root 10. Negative 10 times 5, take 5 root 10. Negative root 10 times root 10, take 10 all over 9. So this comes out as 25. The 5 root 10, take 5 root 10, take 10 on 9, which is 15 on 9. They want me to show that that one equals c on a. C on a is equal to, I can simplify 15 on 9, that comes out as 5 on 3. C on a equals negative 5 on negative 3, which is also 5 on 3. Therefore, alpha times beta equals c on a. And they are actually useful facts that used to form a huge part of this course, actually. Yeah.